Okay, it has been started. And let me share my screen. Mm, okay. Right. So now we'll look at the structure. Right. So this is very important actually. Directly based on the electron configurations we learned in the previous module, because in drawing the Lewis structures, we should know their valence electron configuration or the electrons present in their outermost shell. Right. So, with an example, I just consider the nitrogen. This is an example. Nitrogen. So when I write the electron configuration for the nitrogen, I know it is, hmm, okay, it is S2P3. Right. So that means I would consider all like you would wonder like, okay, here is the co-electron, right? Whatever inside, we call it is the co-electrons, and these are the valence electrons. So we'll indicate these the 5 electrons like this, right? Okay, that's basically the how we can indicate the Lewis structure for just the nitrogen or the valence electron configuration. Right. Now we are trying to draw these Lewis structures. I hope you have reviewed my videos I posted under this particular module explaining how to explain the structures, um, that how you can draw the structures for some like the sulfate ion and another one more structure. I'm sorry, I cannot recall, but there are 2 videos I posted there, so please review that. But again, let me list down those the rules. When we have nitrogen, how many valence electrons from the nitrogen? There are 5 valence electrons. Hydrogen brings just 1 electron. So we have only one nitrogen, so therefore it contributes 5 valence electrons, and hydrogen gives one, but there are 4 hydrogens. So I multiply that by 4, right? Then it brings 4, and altogether I have 9. But there is a plus 1 charge, plus 1 charge. Oh, okay. Plus 1 charge. Uh, that- so then I have to remove 1. So altogether, this has 8 electrons. Good. Right. So 8 electrons. So I divide that by 2. Then I should have 4 electron pairs. Right. When we are drawing this, since this is just the 2 elements, so uh, and 2 elements. So what would be the central atom? You all know hydrogen has the valency plus like 1. Valency is 1. It can make just one bond. So we cannot bring the hydrogen to the central atom. Therefore, we bring the nitrogen as the central atom, and we now combine 4 hydrogens like that. Okay. And the charge we should so now we made the 4 uh, bonding pairs, right? That means, okay, that's correct. We got that the 4 bonding pairs, because those are the one bond means one electron pair. So, and then you draw this, the charge. Hmm. Okay, what's going on? When you mention the charge like that. Okay, right. So that's the Lewis structure for the ammonium plus 1. Next one. Let me get a different color for that. Okay. Now I have HCN. Right. H gives me what is the how many valence electrons? 1. And there are only 1 hydrogen. So I have 1. Carbon, how many valence electrons? 4. So there is only 1 carbon. There we go. 4. Nitrogen. Again, okay, it has 5 valence electrons. Hmm. So altogether, there are 10 valence electrons. There are no charges, so that's the total. Then I divide that by 2 to find the number of electron pairs. Then I get the 5. So in this molecule, I should have 5 electron pairs. Right. Now I have 3 elements in the molecules. What must be included in as the central atom? Central atom. The most electron positive one will be the central one. Therefore, I would choose the carbon. Right. Oh, right. So now I connect the other atoms. Okay. Mm. Here I connected the hydrogen, and there I connected the oh, nitrogen. Right. Now, how many are the electron pairs? Right. The valency of the carbon. Right. There are 5 electron pairs. Okay. So I have taken only the 2 electron pairs out. Now I have 3 more electron pairs, right? So I'm going to add 1 on the carbon, okay? And 1 more on the nitrogen, right? And 1 more. Why I cannot put another one on carbon? How many valence electrons I can have on carbon? Only 4, right? So that's why. But look at the valency of the carbon. The valency of the carbon is not 2, right? And the valency of the nitrogen is also not 1. Um, and look at the octet now. Seems like the carbon and nitrogen doesn't have octet. So we should make an octet on carbon and nitrogen. Hydrogen, it is okay. Hydrogen can have only 2 electrons in its shell. So it is okay for hydrogen. But carbon needs 8 electrons. It has only 1, 2, 3, 4, 5, 6. 6. So I would make a double bond between the something. Carbon and nitrogen. And here I can bring another lone pair from the nitrogen towards the carbon and nitrogen bond. Here I'll make then carbon, carbon, and here is another double bond, and here is it. Right. Okay. Now count the number of the valence electrons on nitrogen. 1, 2. When we count in the the octet, we count the all the both electrons, keeping it or bringing it or considering it on the or at its valence shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the octet on nitrogen is good. Right. Next, let's count the octet, the electrons on the carbon. 1, 2, 3, 4, 5, 6, 7, 8. Right. The octet is 4 on both carbon and nitrogen. So that's the correct, the Lewis structure. And make sure you show that the lone pair of electrons, the lone pair on nitrogen as well. Right. You have any questions?
Yes. So I know for the central atom, it should be the atom with the most positive electrons. Why? I
Not
guess
not most positive electron, most electron positive.
electron positive.
Okay. Remember we talk about something called electron negativity,
Oh,
the
yes, ma'am.
affinity towards the electrons. So now
Mm-hmm.
you think the opposite of that. So that
Okay.
most electron positive element should be the central atom.
Okay.
Any other questions? Okay. Um, uh, that would be great if, okay, right. Yes. Now, we'll draw the resonance structures. Before we draw the resonance structure, we should draw the correct Lewis structure for this nitrate ion. So, nitrate, one nitrogen brings 5 electrons, and oxygen has valence electrons. How many? 6. There are 3 oxygens, so it brings 18. And also a negative charge. Hmm. So this brings a negative charge, therefore we'll add one more electron. So altogether this will have 24 electrons. So I divide that by 2 to find the number of electron pairs. It's 12. So now I draw the Lewis structure for the nitrogen. So what is the most electron positive atom? Oxygen or nitrogen? Nitrogen. So I got the nitrogen here. Um, so here I connect 3 oxygens mm, to this nitrogen. Right. Now, how many more electrons on this the nitrate? Okay, now next I should complete the octets for the terminal atoms. That must be the first thing I should do. 1, 2, 3, 4, 5, 6, making the octet for oxygen. Next, making the octet for the other oxygen. Right. Now, let's count the number of electron pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So, all the electron pairs are Good, right. I don't have any more electron pairs. But look at the nitrogen. Nitrogen does not have the octet. How can I make an octet on nitrogen? Yes, so I should see, get this one of those lone pairs and donated it towards this. So the correct Lewis structure would be nitrogen, double bond, oxygen. Now with that oxygen has two lone pairs, and here is one, the other oxygen, and here is the next one. Right. So this oxygen is -1, this oxygen is uh okay. Oh. Right. Okay. Um right. This is the correct, the Lewis structure for the nitrogen. So we'll add that. I have hard time with this pen. Right, this is the correct Lewis structure. Now, how we can draw the resonance structures? When we draw the resonance structures, we take this arrow. The both side, it has the hedge to the both side. So how can I make the resonance structures? I can donate a lone pair on here and donate this pi bond back onto the other oxygen. So then this is another. Oh, hmm. Now this becomes okay. I will not put anything here and here. Now what's going on? I make a double bond here. Oh no. Not that one. And here is that. And here I make the double bond. Okay. So what is my next one? Yeah, I can donate this one here, okay, and take that one, right? Yeah. So you only move when you draw the resonance structures. Keep that in mind. When you draw the resonance structures, you will not break any sigma bonds. You do not break any sigma bonds. You will only break the pi bonds, right? And also you can only move the pi bonds and the lone pairs when you draw the resonance structures. Right. Next one, the sulfate. Okay, let me choose another color. Right. So sulfur dioxide. It has S, so 6 valence electrons, 2 oxygens, 6 times 2. So altogether, I'll have 18 valence electrons. I divide by 2 to get the number of electron pairs as 9. So what is the most electron positive atom? Yes, the sulfur. So I connect now 2 oxygens. Uh, mm, I don't understand what's going on. Right, 2 oxygens here. Now, I complete the octet for the terminal atoms first. 1, 2. So I should add 3 pairs on oxygen. Right. Now, how many electron pairs did I take? did I use? 1, 2, 3, 4, 5, 6, 7, 8. I have one more lone pair. So I add that lone pair onto the oxygen. Right. So is this the correct Lewis structure? No, it is not. Why? The sulfur doesn't have the octet in the as it's the central atom. So I'll take the lone pair from one of those lone pairs on oxygen and I'll make the correct Lewis structure as that lone pair on sulfur, and now this has two lone pairs and this oxygen has the three lone pairs, right? So that is the correct Lewis structure for the sulfur dioxide. Now we can draw the resonance structures. Remember the rule, when we draw resonance structures, we don't break the sigma bonds, we only move the lone pairs and the pi bonds. So I take one side and make sure for anything you don't add more than 8 electrons, okay? We can normally we shouldn't do that. We can add on more than 8 electrons only for that transition metal ion, so no, you don't get that those examples for this level. So keep that in mind. For this S and P block elements, you should not add more than 8 electrons on their octets, right? Okay, so I draw this one, so then I get the the sulfur, and here is a double bond and double bond, and here is the other one, right? Okay, next, another resonance structure. So I can donate this one here, okay? So here is the sulfur. Hmm. I make only a the keeping the sigma bond there. Now this terminal oxygen will get three electron pairs, and here is the double bond and that. You don't break the both things, okay? Both side. We'll at a one time, you make only one or you move only one pi bond. Keep that in mind. So this is a mistake that students usually do. They tend to break two pi bonds at a time. No, you don't break two pi bonds at a time, or don't move two pi bonds at a time. You can, when you are drawing resonance structures, you move only one pi bond or you break one pi bond at a time. That those are the rules. You have any questions? Right. Next, we going to talk about the formal charges. Right. The formal charge also, you can calculate the formal charge. Right. You get the, you count the, okay, here are, you get the valence electrons in a neutral atom minus the valence electrons in its Lewis structure, right? So calculate the formal charges on all the atoms in the following Lewis structures, right? Look at the hydrogen. How many valence electrons in hydrogen, right? Hydrogen has just one electron in its valence shell. Look at the count the number of electrons on the valence shell. When you are calculating the formal charge, you get only one electron from the bond. You don't, when you are calculating the octet, you count the both electrons. But when you are calculating the formal charge, there you will consider only one electron from each bond, right? So hydrogen has one bond, so this is minus. Nitrogen had made just one bond, so it will take one electron. So 1 minus 1 is 0. So the formal charge of the hydrogen in this case is 0, right? Next, I'll consider the argon. What is the number of the valence electrons in that neutral atom of argon? It is 8, right? Okay. Uh, Right, it's 8. So now we'll consider its unshared electrons, right? So how many unshared electrons in the and the bonds? Okay, unshared electrons. So these are, we consider these are unshared pairs because these are not shared with anything else. So there are 6, and then we count one from each bond. 6, 7, and 8. Right. So again, it is 0. Right. When it comes to the fluorine, what is the valence electrons for the fluorine? It is 7. Now, how many unshared electrons here? We count the both electrons on the for the fluorine because those lone pairs are not shared with anything else, right? So 1, 2, 3, 4, 5, and 6. Right, 5 and 6. And it had made just one bond. So 6 plus 1 is 7. Okay. So the formal charge of the fluorine in on this the molecule is 0. Questions? All right. The next one, oxygen. Right. Let me get a different color. Right. The oxygen. Right. How many valence electrons for the neutral atom? 6. Right. Minus. How many unshared electrons on oxygen? 1, 2, 3, 4. Each bond you can count just one electron from towards the oxygen. 1, 2, 3, 4, 5, and 6. So it's 0. Next, this nitrogen. Okay, these are two different oxygens. So we have to treat them different, separately. Okay, right. So this nitrogen, how many valence electrons for nitrogen? It is 5, right? And let's count the unshared electrons here. 1, there is a 1, 2, 3, and 4. Right. So the charge for the nitrogen is plus 1, the formal charge. Next, for the oxygen, right. How many? Okay, the valence shell electron configuration, valence electrons are 6. So minus how many unshared electrons? 1, 2, 3, 4, 5, 6. And plus 1 from the bond. So that's 7, right? So 6 minus 7 is minus 1. So that is the formal charge of that, the oxygen. Okay, the right hand side oxygen. Any questions?
What happens if you have a charge on one of the? I mean, I guess it's the we're gonna see that in the next question. But it just like will we take the charge away from that number?
No, you when you are calculating the formal charges, you
Mm-hmm.
don't get that sort of iron. You will be able to get. Okay, here as an example, look at
Mm-hmm.
the total charge. Look at 0, 0, 0 for this the HARF. Okay, so 0,
Mm-hmm.
0, 0. So the
Mhm.
total charge of this molecule is zero. Net charge is zero. Right.
Okay.
When you look at the NO,
Mhm.
oxygen is zero. Nitrogen plus one, oxygen minus one. So what is the net charge? Is zero.
Because it cancels it out.
Okay. So if there is any charge behind, then or left out, that will be indicated by its the by the by the formal charges of the individual atoms
Oh,
there.
okay. I got what you're saying. So if the first O was O, the N was actually O, but there was a -1 for the second O, then the
Yeah.
formal charge would be 1.
Yes.
-1. Let me
Yes.
go wrong
Minus one.
charge.
So
Okay,
we have
gotcha.
plus one and minus one. They will be cancelled out. So the
Mhm.
net charge for the entire molecule is zero.
Gotcha. Okay. Thank you.
You're welcome. Right. Okay. The next question. There are three possible structures for the thiocyanate ion. Given the formal charges below each atom, predict which one of the following Lewis structures for the thiocyanate is most likely correct. Right. So when we are given the different types, more than one Lewis structure, how do we decide the best one? The best one or the most suitable one should have the less charges. Okay, the less charges. When you look at the now the middle one, okay, it has plus one and minus two. This nitrogen has only minus one charge. This the other molecule, the third Lewis structure has the formal charges on each and every atom. So in that case, we can find the best one as the middle one, okay, because it has the less charges. The most suitable Lewis structure will have the minimum formal charges. That's a one question. And the next one, the most electronegative atoms must have the negative charges. I hope you will understand. Most electronegative atoms will have negative charges. Most electron positive atoms should have the positive charges in the best or the most possible Lewis structure. When you look at this, when we look at this, the CNS, what is the most electronegative one in the three elements? Carbon, nitrogen, sulfur. What is the most electronegative one? Most electronegative one is the nitrogen. So the most stable or the most possible Lewis structure drawn for this ion should have the electron should have the negative charge on the nitrogen for the nitrogen. But look at this one. Here the nitrogen has plus one positive charge, but the carbon has a negative charge. No, carbon is not more electronegative than nitrogen. Therefore, that's another reason why we didn't choose the correct, though the most possible structure as the first one. Look at the second one again. Right. Okay. Nitrogen in this case has a negative one. Okay, good. But the carbon has more negatives on it. Okay, no, it is not stabilizing this molecule, this structure. So that's wrong. But look at the structure we have chosen. Yes, in that case, sulfur is zero. The formal charge for sulfur is zero. The formal charge for the carbon is zero, but the most electronegative nitrogen only has -1. So those are the two reasons we use to choose the most possible Lewis structure or the correct Lewis structure when we are given more than one Lewis structure. Right. Any questions? Right. Okay. Um, I hope now we have covered the two worksheets, and I'm going to stop the recording now. Stop. Right. Okay.